For centuries, the way we cook has been determined by our surroundings. If tomatoes and basil grew in the same soil and shared the same climate, they ended up on the same plate. But human intuition has limits. We are restricted by the cultural habits we were raised with, which makes us physically incapable of sorting through the millions of potential chemical combinations found in nature. Take a pairing like coffee and garlic. To a person, combining a roasted bean with a pungent allium sounds like a mistake. But to a neural network, a computing system modeled on the structure of the human brain, the chemical overlap is obvious. Algorithms look past cultural associations to examine the underlying molecular structure of the food itself. The most innovative chefs working today are no longer solely human, but increasingly advanced data processing algorithms. For decades, the highest honors in the culinary world have been awarded to people who mastered the art of human intuition. We are moving away from what grows in the local soil and toward what is calculated in the database. This shift requires moving out of the kitchen and into the realm of raw chemical data ingestion. Scientists are building a digital palette. This is a searchable neural database where the chemical fingerprints of thousands of ingredients are cataloged. Instead of recognizing a whole ingredient, the system breaks foods down into specific volatile chemical compounds, the molecules responsible for flavor. By analyzing thousands of these constellations at once, the database identifies shared nodes between completely unrelated foods. Generative models, AI systems trained to create new data based on existing patterns, use these identified overlaps to predict combinations no human has ever tasted. The software isn't just slightly altering an old recipe, it is calculating balanced pairings that do not follow traditional human logic. These mathematically derived profiles are already used to develop new commercial snacks and high-end tasting menus. By bypassing human bias, algorithmic synthesis creates flavor profiles based on molecular compatibility rather than regional history. Flavor is only one part of the dining experience. A complete dish also requires a highly specific physical structure. Machine learning is now used to engineer precise sensory perceptions, specifically the structural integrity and mouthfeel of what we eat. This technology allows researchers to create realistic physical alternatives to meats and cheeses by manipulating plant-based proteins, ingredients derived from sources like peas or soy. This chart shows how researchers use data to optimize the mechanical properties of a dish. The algorithm adjusts variables to hit exact target values for viscosity, crunch, and thermal resistance. This engineered texture is built to complement the AI-generated flavor profile. Artificial intelligence is now capable of architecting the entire sensory sensation of a bite from the molecular level up. These theoretical data points eventually have to leave the screen and enter a physical commercial kitchen. What emerges is a loop, where human chefs and data scientists run automated recipe iterations. This flowchart illustrates that cycle. The algorithm generates a concept, the kitchen executes it, and the sensory feedback from diners is fed back into the system to refine the next iteration. Code now functions as a primary ingredient, dictating how a dish is conceived before a chef even picks up a knife. We are seeing a partnership between human execution and machine precision. The future of gastronomy will be defined by our ability to transform raw chemical data into sensory experiences that are no longer limited by history or geography.